Hello guys, welcome back to VC Tech. In most networks, the default gateway is the single most important device in a network. But what happens if the default gateway fails? In this video, I'm going to explain HSRP or Hot Standby Router Protocol, what it is, why it is required, and how it keeps network online even when a router goes down. By the end of this video, you will clearly understand how HSRP works, why it is important in a real network, and why redundancy is not optional in modern networking. With that being said, what is HSRP? HSRP or Hot Standby Router Protocol is a Cisco redundancy protocol that provides virtual default gateway for host devices. If the active router fails, the standby router automatically takes over. Why is HSRP required? End devices rely on a default gateway. A single default gateway creates a single point of failure. HSRP removes downtime by ensuring gateway availability. The benefits of HSRP includes high availability and redundancy, automatic failover, no configuration changes required on host devices, and improved network reliability. How HSRP works is the router shares a virtual IP and a virtual MAC address. One router is the active router and the other is the standby router. Host devices always use the virtual IP as their gateway, and failover happens transparently. If the active router should go down, the standby router take off transparently without the host devices even noticing there was a network downtime. With that being said, let's head over to our configuration phase where we'll be configuring HSRP on a router, where we will decide what router is the active router and what router is going to be the standby router. For this tutorial, we are going to be using 3 routers, 1 multi-layer switch that will be serving as a layer 2 device, and also a couple of host devices. So before we get into the configuration, this router over here will be serving as the active router, while this router over here will be serving as a standby router, as we have here the standby router and the active router. So how do we configure HSRP on a router, specifying what router should be active and what router should be the standby? So what we do is we head over to the router and to the interface. Remember, this is HSRP in a simple term means having a backup default gateway. So once the active router goes down, the standby router kicks off. Just see it as a backup router or backup route for when the main route fails, the standby route takes over. So we are going to configure HSRP on interface gig 0/0 because it's going to be serving as a default gateway to this host devices. So on interface gig 0/0, I've already assigned IP address to this interface, and the interface has the IP address of 192.168.1.3. So let's configure HSRP on this interface that already has an IP address. So what do? We say standby. We want to assign it a group number, standby group number 10, and this is where we assign the virtual IP address that the host devices will be using to leave the network. So the virtual IP address is going to be 192.168.1.1. By doing this, we've configured a default gateway for the host devices. Now let's specify on the router which router becomes the active router and which router becomes the standby router. We do that by assigning a priority number. We say standby with a group number of 10, and we want the priority of this router to be 110 because we want this router to be the active router. And the way HSRP works is the higher the priority number, the more likely for that router to become the active router, while the lower the priority number, that router becomes the standby router. So this router will be taking 110 as the priority number, and we want this router to become the active router. Now there is something else we need to do. We want to also assign the group number of 10, and we want to say preempt. So what this line simply means is whenever the active router goes down and the standby router takes over, whenever the active router comes back on, the active router should take over from the standby router. That is what this line here means, standby 10 preempt. So by doing that, we've configured HSRP on this router, specifying that we want this router to serve as the active router for the default gateway of this local area devices. Now let's also do the same configuration here, enabling HSRP and also letting it know that it is going to be serving as the standby router. So interface gig 0/0. We also want to assign the standby virtual IP address. So group 10, standby group 10, and the IP address should be 192.168.1.1, which is the virtual default gateway for the local area devices. Now we also want to set the priority number, so group 10, and we want to say the priority for this router should be 100, and we want this router to serve as the standby router. So if you notice, we did not configure standby with a group number of preempt because we want whenever the active router goes down and the standby router takes over, if the active router should come back on, we want transmission of HSRP to be transferred back to the router we configured to serve as the active router. Now we've configured HSRP on both routers, so let's also check which router is the standby router and which router is the active router. So we do that by saying do show standby. By doing that, we saw that Giga Ethernet ports is in group 10 and this router is the active router. It also has the virtual IP address of 192.168.1.1, which will be serving as the default gateway for the local area network, as well as it has its own MAC address. And as we configured earlier, preemption is also enabled, and active router is local, meaning the router that we are on right now is the active router, and it is also showing us the standby router IP address, which is 192.168.1.2. We can confirm that by going on the router 192.168.1.2, and we have the priority for this router to be configured at 110. Now, since we've seen all that, let's head over to the standby router and do the same and see what we get. So do show standby. So Giga Ethernet ports is in a group 10, and state of this router is standby. It has the same virtual IP address that will be serving as a default gateway and the same MAC address. So it is showing that preemption is disabled and the active router is 192.168.1.3. That is what it is telling us, that the active router, which is this router over here, has the IP address of 192.168.1.3, and standby router is local, meaning the router that we are on right now, which is this router over here, is the standby router, and it has a priority number of 100. So guys, this is how we configure HSRP, or in a simple term, a backup route for a default gateway. Whenever one router goes down, the other router takes over. So let's ping with the host device and see what route is going to be taken to get to that destination. So let's see, ping 192.168.20.5. So as you can see, we are able to ping the host device from this local area network. Let's check what default gateway or what route is taken to get to that destination. We can do that by saying we can press route 192.168.20.5, As you can see, it is taking the active router interface to get to its destination, which is 192.168.20.5. However, HSRP is a first hop redundancy protocol. It is not a routing protocol, as it does not determine what routes that traffic gets to its destination. What it does is it only provides redundancy for a default gateway, and it specifies what router serves as the active router and what router serves as the standby router. Let's also check another way we can see what router that we are on. So do show standby brief. As you can see, gigaport 0.0 group 10 has a priority of 100, and the state is also the standby, and it is also telling us that the active router has the IP of 192.168.1.3, and this is the virtual IP address that the host devices will be using to get to whatever destination they want to go to. So this is how we configure HSRP on a router, enabling redundancy of the default gateway for the local area network devices. Thank you for watching this video, and see you in the next.